Hi, everyone, and welcome. My name is Aaron Smith. As always, I'm joined by Nancy Bakeman with the Energy and Environmental Building Alliance. We're really excited today to have Rob Howard with us. Those of you that have known, Rob has been a friend of EBA for many, many years. Rob has Howard Building Science now and is going to take us through his journey to net zero energy ready home builder. We've got a lot of slides. We're going to hold the questions till the end. So if you can put your questions in the Q&A section, that would be absolutely fantastic. Rob is also a member of the Builder Benchmark Group at EBA, and we're extremely pleased to have him as a member of that group. So with that, Rob, Nancy and I will turn it over to you.
Thanks, guys. Nice to be with you again. Is my video working okay?
Yeah, you look good.
Okay, everybody can see the slides. So as you guys know, the title of the presentation today is Sustainable is Attainable, which is has become kind of a tagline for me. That's essentially what I'm trying to do here in Western North Carolina, is prove that sustainable is attainable. I'm not going to read the learning objectives to you. My apologies to whatever continuing education you might or might not be getting today. So just by way of introduction, as Aaron said, I'm Rob Howard. I'm a builder developer in Granite Falls, North Carolina, kind of between Charlotte and Asheville and Boone, if that helps triangulate where my location is. And in addition to being a general contractor in North Carolina, I'm also a lecturer at Appalachian State University. I'll tell you a little bit more about that story in a little bit. And some of you guys may remember me from my time either at Mitsubishi Electric Train HVAC US LLC as a part of the performance construction team there. And then prior to that, I spent 15 years of my career with Habitat for Humanity, 10 years as the construction manager for my local affiliate here in, it's called Catawba Valley Habitat for Humanity, and then 5 years as a sustainable building specialist with Habitat International. Just a little more background on Habitat for Humanity of Catawba Valley, which is based in Hickory, North Carolina. I still say we because I'm now on their board. So I'll always feel like I'm a part of the team there, I guess, but that affiliate has been building Energy Star homes through Advanced Energy's System Vision program since 2001. So a long, rich history with building above code homes. And I guess really set ourselves apart back in 2005 when we built the first net zero energy home in North Carolina, which was a grant funded project through the State Energy Office and the Appalachian Energy Center in Boone. And then 10 years later, we built the first DOE zero energy ready homes in the state. And I'll tell you more about that story as well. Just a little more information about that zero energy home that we built back in 2005. Again, it was a partnership with the Appalachian Energy Center and is at its core a passive solar design. It's actually listed in the Affordable Passive Solar Plan book that the Appalachian Energy Center published way back in 2005, and you can still access that through their website. It has a insulated concrete slab. It is, as you can see in the pictures there, it's a stem wall foundation. This is not slab on grade. So we backfilled that stem wall foundation and then put in quite a bit of rigid insulation and poured the slab on top of that. It's got R25. It's actually Icynene spray foam. It's the first house I ever built that had spray foam insulation. It was open cell in a 2x6 cavity. We did use advanced framing techniques with this house, and it's the first time I ever built a house with 2x6 exterior walls. Everything we'd done prior to that had been 2x4. And then, back in those days, I think R30 was probably code for attic insulation, and we had to, we took this thing to R49. So quite a bit of insulation in the attic. And also the only home I've ever built that had a geothermal heat pump. The Appalachian Energy Center was able to get quite a few donations for this project, including the geothermal system,
Rob,
as well as that's.
did you do a well or a field on that?
It's a horizontal trench. Actually, it basically traces the driveway there that you can see in that lower picture. So it was a little more affordable for that reason. You know, we didn't have to do wells there. We still struggled with our heat transfer on that thing, though. It never really it did well in the winter, but never really did so well in the summer. She had some, and as you can see, you got a lot of south facing glazing with that passive solar design. And, you know, even though we sized the overhangs, you know, according to, you know, passive solar design guidelines, you get a mild winter day with all that that south facing glazing, and you're running the AC in the wintertime. So I learned some valuable lessons, like I do on every house I build.
Sure.
But I guess the crown jewel there on the roof, you can see the 4.8 kW PV array that did in fact make that a net zero energy home, at least for the first couple of years that we were tracking the energy bills. So that was really, you know, sort of a pivotal moment in my career. It really changed the way I thought about construction, and actually was what inspired me to want to become a HERS rater. Went down to South Face Energy Institute in Atlanta and got my HERS rater certification in 2006, right after building that house. So I want to tell you a couple of stories. They're labeled case studies, but I'll try to make it more of a narrative. So this Northstone is a mixed income community that we developed in Hickory when I was still at Habitat for Humanity. And it's this is one of those where the original developer unfortunately got stuck in the recession and was not able to get out from under this thing. So it ended up going back to the bank. Habitat bought it for pennies on the dollar, and all the infrastructure was in place. We literally just went in there and started pulling permits and building houses. But because this was in a nicer part of town than we were accustomed to being able to buy land in, we decided to do this as a mixed income community. So it's roughly half Habitat homes and half market rate homes. And the homes that we sold on the open market, we took the profit from those and basically used that to build more Habitat homes. This is the first project I did with Tight Lines Designs, which is an architecture firm in Raleigh, North Carolina. They do a lot of affordable housing design, both single family and multifamily. They do a lot of low income housing tax credit projects, really all over the country, but primarily in the Southeast. You know, this is an ad that we took out in our local newspaper back in 2015 on Earth Day, just to promote the type of construction that we were doing in Northstone. So first time we had ever certified homes to the DOE Zero Energy Ready Home standard. And so just want to, you know, give you a little more background information on the changes that we had to make to our construction practices in order to certify. This is DOE language right out of Zero Energy Ready Home. You know, this, so you guys probably are familiar with this program, but want to dig into the technical specs a little bit. Of course, you do have to certify the home to both Energy Star and EPA Indoor Air Plus as basically prerequisites. And they added on a renewable energy ready checklist that the builder is responsible for filling out. And then I guess the one that I'll draw your attention to, which, you know, is one of the things that we had to figure out as a builder, and, you know, I think might be one of the things that, you know, trips some people up, is trying to get your HVAC, your mechanical system, and certainly your ductwork inside the thermal and air boundary of the home. So how do you do that? Well, there's a couple options, and we ended up doing the closed crawl space option because this land is not exactly flat. It's got a little bit of slope to it, and crawl spaces were kind of our go-to foundation type anyway. So we elected to move our building envelope, the thermal envelope, from the floor to the foundation walls, similar to that picture on the left. Of course, that also means you have to have a drying mechanism in that crawl space. So we'll look at a detail on that in a minute. Other options we explored were, you know, doing an unvented attic with insulation at the roof deck. And certainly if you're building on a slab foundation, that may be your only logical option. But the architect and builder favorite, of course, is drop soffits or ceilings. And I'm kidding, of course. None of us really like to deal with those kind of details. So most people try to avoid that. But I guess, putting my Mitsubishi hat back on for a moment, the other option that I think is, important to consider is, do you really need ductwork? Or could you do some kind of high performance alternative like a ductless mini split? So again, digging into the details here a little bit on the what I started to refer to as affordable zero energy ready homes in Hickory. You see some of the features and benefits there, which are pretty similar to the DOE list you saw earlier, but we added on a few things there at the end with universal design for aging in place, as well as a homeowner education program, which I think is really important. Again, closed crawl space foundation, we were required to do R10 on the foundation wall. Of course, had to upgrade our vapor barrier on the floor of the crawl space. And then for our drying mechanism, we elected to do a dedicated dehumidifier in that space. Our code in North Carolina, which was the section on closed crawl spaces, was basically written by Advanced Energy in Raleigh, but they also allow you to do positive pressure supply air from your HVAC system, that as another option. Or you can actually make that a truly conditioned space, but that puts you into some other requirements that we just didn't want to deal with. So we elected to go with the dehumidifier for that. The exterior walls on these were also 2x6, 24 on center with R21. Sometimes you'll hear this referred to as bibs, the blown in blanket system, where they stretch a netting across the face of the studs, and then they basically dense pack dry blown fiberglass in behind that netting. So we were able to get to R21 in those cavities. And then I don't know if they still do, but back in those days, we had a gift in kind relationship with Dow, now part of DuPont, where we were able to get their styrofoam insulation that we called Blue Board for free. So we were using 1-inch Blue Board or styrofoam on the exterior there, which got us another R5. And you can see in that detail on the right there, we installed furring strips on top of the foam, anchored that back into our 2x6 framing, and then we hung our LP Smart Side on those furring strips so that we're getting a drainage plane behind our cladding. We were doing vented attic assemblies on these houses, and we were blowing somewhere around R49, R50, either fiberglass or cellulose in the attic. And certainly we recommend the use of either reflective metal or light colored, ideally Energy Star certified shingles. But in our case, we also had a gift in kind relationship with, I believe it was Certainteed, that was donating shingles to us back in those days. So if you're getting it for free, you'll take whatever color they give you. And then Northstone was the first time that I had ever used mini splits of any kind on homes that we were building. So we selected Mitsubishi as our vendor for those, and we were fortunate that our HVAC contractor that we'd been using for years was already a Mitsubishi Diamond contractor, was familiar with that equipment. And we started with what a lot of people call a ducted mini split that was located in that closed crawl space. And you can just barely make out the air handler. I don't know if you guys can see my cursor there, but these things are quite small. It's kind of like an old school suitcase laying on its side. The bulk of what you see in that picture is actually a return plenum that the contractor built to try to quickly transition from what you'll sometimes hear squared around or rectangled around flex ductwork. We also did a few houses in Northstone with ductless mini splits, and I'll show you kind of how we innovated, maybe as a way to describe it, on the air distribution strategy in the houses that had ductless heat pumps. So we experimented, quite frankly, with a couple of different methods. Some people refer to these as transfer fans. We used these Panasonic Whisper Value fans that are 3.5 inches deep, so you can install those vertically in an interior wall cavity, and they actually make a little, I think they call it a transfer register box accessory for that fan. So you can literally pull conditioned air from one side of the wall and supply that directly into the bedroom. And they have a couple of different controls strategies that you can utilize for that. And then the other air distribution strategy that we used in a few of those houses was a whole house filtration system. This is actually a Fantech product. It comes standard with MERV 13 filtration. So, there's an added benefit. We're getting high efficiency filtration from this device. And they also have the option of upgrading that to a HEPA filter. So up to 240 CFM, that's probably with, very little ductwork on it. But we had plenty of airflow for, say, a 3-bedroom, 2-bath, 1,200 square foot house. And as you can see on the back of that there, you have a supply and a return collar right there on that unit. So it's basically like a mini air handler in a way. Our mechanical ventilation strategy, pretty standard as far as spot ventilation is concerned in kitchens and bathrooms, but we had to upgrade when we started certifying to Zero Energy Ready Home, and to meet the Indoor Air Plus standard, we decided to go to ERVs on these houses. The one picture here is a Venmar product. Those are now being sold under the Brone label in the US market. So that's what the Habitat affiliate is using now. And actually it's the same product basically that I'm using in the houses I'm building today. Another strategy that we tested on a few houses was the ventilating dehumidifier option. The one pictured here is actually a split system dehumidifier. I don't know that Thermistor is even manufacturing these anymore, but that was called the SD12. And that outdoor unit, as you can see there, looks a lot like a mini split heat pump. So the beauty of that system is your compressor's outdoors, and you're moving the noise and vibration of a compressor to the outdoors, but you're also dumping the waste heat from that outdoors. So what you end up with as really a byproduct is about 1/3 of a ton of cooling off that unit. So I thought it was a pretty cool device. Unfortunately, it was also very big and quite expensive as well. We also, one of the upgrades to get Zero Energy Ready Home certification was we switched from a conventional electric storage tank water heater to heat pump water heaters. The first, and again, this has been a few years ago. So we were originally using the GE Geo Springs back when those were still being manufactured. I don't know what brand they're currently using. I'm actually using a Ream on the houses I'm building today, but I'm definitely a big believer in heat pump water heaters. You can see the ridiculously high energy factor on these things, and the only downfall or downside is you've got to deal with the cold air exhaust coming off this thing. And I guess if you're in a cold climate, the fact that it's potentially stealing heat from the ambient air, depending on where you install it. But I'm actually doing the same thing we were doing at Habitat. We were putting these in an attached storage closet right off the back porch. So it's not technically inside the envelope. I guess the other thing to point out there is that your electric utility will often have a rebate for heat pump water heaters, and we were getting $350 per house from Duke Energy on those. We were actually not, because of our EPA radon zone, we're in zone 2 here. We were not actually required to install the passive radon vent, but we went ahead and did it anyway, just because it's so easy and cost effective to do this during construction. And if you've ever had to come back and retrofit a house with one of these after the fact, it's not fun. So and not pretty. So it's much better to try to basically hide this inside the framing, similar to the way you would a plumbing stack. So, and fairly inexpensive to accomplish. And then, of course, in addition to installing the PVC vent, you'd also want to give easy access to an outlet, probably in the attic, in case anybody ever had a high radon test and needed to activate that system later. I guess the other thing that we were really challenged to do by the EPA Indoor Air Plus certification was dive deep on the MSDS sheets, for all the building materials that you're using, because they require low VOC or no VOC paints, stains, composite or engineered lumber, has to be formaldehyde free. And as you guys know, it's a lot of the building materials that we use today are engineered products, and they tend to be fairly heavy with adhesives. And the reality is we're dragging a lot of chemistry into the built environment through the materials that we use. So that's probably the biggest learning curve I had for this certification, was really going to school on what is in these materials that we're using, and what might we be exposing our homeowners to, who are going to live in these homes, and trying to keep that as, make better choices as it regards our supply chain. You're also required to do an efficient plumbing distribution system. So I say thank you to Gary Klein, because I attended several of his workshops over the years, either at building science conferences like EBA, or he also came to the Habitat International affiliate conference a couple times in Atlanta. So I learned most of what I know about efficient plumbing from Gary, but trying to keep the water heater as centrally located as possible, and of course keeping your plumbing runs as short and straight as possible to your hot water fixtures, insulating at least your hot water pipes, and of course kind of a no-brainer to be using WaterSense fixtures at this point. To me, that's almost like telling people they need to use LED light bulbs. They're readily available across the lineup. You don't have to buy the high-end plumbing fixtures to get WaterSense labeled fixtures. One of the other initiatives that we started when I was at Habitat International was what we called Habitat Strong. And in a lot of ways, this was a response to the hurricanes in the Gulf and the damage with the IBHS Fortified Home Program, and created a, sort of a habitat version of that. So you can see some of the basic things that we wanted to upgrade to our homes to make them more resilient to natural disasters. Things like attaching your roof sheathing with ring shake nails, taping the seams of your roof sheathing in case you have a high wind event where your shingles come off, your underlayment comes off. Of course, you're required to have space between if you're using OSB sheathing, certainly you've got spacers in there for expansion and contraction. So the water can obviously go right through that. So having those seams taped gives you, kind of a belt and suspenders approach. So if you're using the zip system, that's obviously built into what you're already doing. We also had to reinforce our gables in the attic and add drip edge, which actually we were already doing. And then we had already been, kind of moving in this direction, because Habitat International certainly encourages affiliates to think about universal design principles. But having at least one 0-step covered entrance with a 3.0 door, and at least one accessible bedroom and bathroom on the main level of the home. Most of the homes we were building were 1 story, so that wasn't hard to accomplish. But ideally, those would also have 3.0 doors, so a little bit wider doorways, wider hallways, using lever style door handles and faucets. These are things that make everybody's life easier, whether you have dexterity issues or mobility issues or not. and just blocking for grab bars, and hopefully noting where those are located in case folks need to add those later. And then I guess the other piece I want to mention is this homeowner education program that we developed, really to help our buyers understand the benefit of the ways we were upgrading these homes, and then also to make sure that they stayed high performance and healthy, energy efficient homes over the years. So we utilized a curriculum that was developed by the National Center for Healthy Housing. If you guys are not familiar with that group, I would certainly encourage you to check that out. They've partnered with HUD to develop these healthy homes training programs over the years, and they've got resources that are free and that are easy for homeowners to understand. So that was kind of phase one, was that healthy homes training. Phase two was our walkthrough, which probably every builder is doing a walkthrough with their homeowners before they move in. So but that we realize that people are kind of drinking from a fire hydrant at that point after they've just closed and signed their life away. So we really wanted to add another phase to this. So phase three for us was what we developed was a 2-year monitoring and maintenance agreement that the homeowners had to sign. But in exchange for that, we included a 2-year maintenance agreement with the HVAC contractor. So basically we were throwing that in with the cost of the house, and now they're going to get 4 visits, usually spring and fall, over the first 2 years that they live in the home, to make sure that the HVAC equipment is running at its highest efficiency, filters are being changed, things are properly charged and so forth, and certainly try to catch any issues while equipment is still under warranty. We also asked for access to their energy bills, and in some cases actually installed some relative humidity and temperature sensors in various parts of the house, just to see if things were really working effectively. So how did we do? Well, the first 2 houses that we built in Northstone, this is the energy modeling results from those. So the first house, the one at the top right there, is the Tight Lines Julia plan. This is actually a 4-bedroom version of that plan. So a little bit larger than what we were accustomed to, 1,340 square feet. You can see an extremely low heating and cooling load, around 1 ton. And at that time, it was the lowest HERS score home I'd ever built. We were used to seeing HERS scores in the high 50s, low 60s. So to get one down in the 40s was really phenomenal for us. And then the second home we built in Northstone, the Tight Lines Hawkins plan, is a 3-bedroom, 1,250-ish square feet, about the same heating and cooling load, and had a HERS score of 46. And you can see some of the certifications here. Zero Energy Ready Home, and as I mentioned before, includes Energy Star and Indoor Air Plus certification as well. And then I guess the other thing to mention is the System Vision program from Advanced Energy. They run this in partnership with the North Carolina Housing Finance Agency, and they offer a grant somewhere around $4,000 a house to affordable housing providers who certify their homes to this System Vision standard, which is similar to Energy Star, but with some additional requirements that are specific to affordable housing providers. And what's unique about it is they provide a 2-year comfort and energy use guarantee with the home. So they're only guaranteeing the heating and cooling portion of the bill. So they've got a formula that they use to try to calculate that. But you can see this home's energy or heating and cooling bill was guaranteed at $30, for the first 2 years they live in the home. And they even, list the kilowatt hour usage there. So if it exceeds that amount, Advanced Energy will actually send somebody out to try to troubleshoot and figure out why it exceeds their predicted rating. So one of the questions I always get is, well, if this is affordable, how much does it cost? So these numbers are, definitely dated at this point, but, so take yourself back to 2015 here. But I tried to break out the upgrades to get to zero energy ready home, and anything that was specific to either Energy Star or Indoor Plus. Our total cost increase on those houses was around $6,000. And once you back out some of the incentives that we were getting, either that grant through NCHFA or, the county actually offered a permit rebate for Energy Star homes back then. We were getting that heat pump water heater rebate from Duke Energy. We got the Dow styrofoam for free through that gift in kind program. Same for Valspar paint, by the way. So we were able to get low VOC paint for free. And our rater was kind enough to donate their services on these houses. So we were actually coming out of pocket around $2,900 a house, which I feel like was extremely cost effective for the level of performance that we were able to achieve with these homes. We also applied for the DOE Housing Innovation Awards for a couple of years there during that Northstone construction. And you'll see we were quite successful there, had quite a run. 2016, we won a Housing Innovation Award for that Julia plan that I talked about a second ago, that came in at a HERS 44. 2017, we got another Housing Innovation Award for that Hawkins plan that I showed you, that came in at a HERS 46. 2018, we won another award for this 3-bedroom version of the Julia plan. It's 1,240 square feet, came in at a HERS 49. And in 2019, we won another Housing Innovation Award for I'm forgetting the name of this house plan now, but a little bit smaller, 3-bedroom. And I think I'm saying this correct. I think this is still the lowest HERS score that I ever got on a house that I was the GC on. It came in at a HERS 40. So I'm going to switch gears here and tell you guys a little bit about my work with Appalachian State University in Boone. Aaron, do we have any questions in the chat that I should take a breath and
No,
answer?
sir. Keep going.
Okay. All right. Well, in that case, I won't take a breath. So I'm part of the Department of Sustainable Technology and the Built Environment at App State in Boone. I started my relationship there really in 2005 with that zero energy home we built in Hickory. But as an instructor, they asked me to teach classes part-time starting in 2010. And I did that until I started the job with Mitsubishi in 2016. Unfortunately, I was just traveling too much with that job to be able to keep doing that. So took a couple years off there. I was taking some grad school classes, though, slowly working on a master's degree in building science. And I was doing a 4-year paid internship at Mitsubishi, so it was very kind of them to pay for grad school for me. But during that time, I was also fortunate to be able to participate as both a student and as a juror in what used to be the DOE Race to Zero, now called the Solar Decathlon Design Challenge. I'm actually a faculty advisor for we have 3 teams in the Solar Decathlon Design Challenge this year. In fact, they just did their semifinal presentations this past Friday and found out on Saturday that all 3 of our teams made it to the finals at NREL in Golden, Colorado in April. So we are super excited about that. I also have taught these workshops for the Appalachian Energy Center over the years, and we actually taught these at the Hickory campus, closer to where we were building those habitat homes in Northstone. So we would spend the morning in the classroom talking about the same things we're talking about today. How do you build an affordable zero energy ready home? And then we would take them out in the field in the afternoon and tour the houses, ideally get to see some in construction so that we could look at some of these details in person. I'm not going to spend a lot of time on this, but I do want to just give you an overview of what ended up becoming my graduate research in my master's program. I had spent, a couple of years with Mitsubishi working on that performance construction team. And, one of the things we focused on a lot was what I would call low load homes. So we talk a lot about high performance or net zero, certifying homes to a standard like zero energy ready. But, what we end up with is a home that has an extremely low heating and cooling need. So as part of my graduate research, I was looking at what are HVAC equipment options that are available on the market today that are appropriate for these low load homes. And, it's probably no shock to you guys that there aren't very many. There aren't nearly enough. That is for sure. But as part of that research, I read this report from PNNL on they had done a review of residential low load HVAC systems back in 2013. So in some ways, this was an attempt to kind of update this report. As part of that, I read Manual LLH, the low load home manual that ACA published a few years ago, and trying to understand how do we define a low load home. And ACA would say that a low load home is one in which the design, heating, and cooling loads do not exceed 10,000 BTUH per square foot of conditioned floor area. So, just to give you a couple examples, a 1,200 square foot dwelling, which, I built a lot of those when I was at Habitat, would have a design heating load of around 1 ton. And a 2,000 square foot dwelling would have a design heating load of somewhere around 20,000 BTUs, just under 2 tons, or just over 1.5 tons. So what we often will say is, we're running at part load most of the time. So, when we do a load calculation for HVAC systems, we're really looking for the worst case scenarios, the hottest days and the coldest days of the year. Are we going to have enough capacity to meet the load at those times? But in reality, 99% of the time, we're running at some part load. So does your equipment have the ability to adjust its capacity accordingly? And the reality is most equipment does not. So what's the problem? Well, small heating and cooling loads also translate to equipment, and that equipment has lower CFM available to mix the air in the home. So while you don't need a lot of BTUs generated, you do need a sufficient amount of airflow to move those BTUs around the house to keep it consistently comfortable. So what we end up with is a room air mixing problem. And of course, that can also lead to indoor humidity control problems. But ultimately, it just makes it really difficult for HVAC contractors, mechanical engineers, designers to do proper equipment selection. And if we ignore these problems, then the result is we have comfort issues. People are not they're not comfortable in their home, and that's a problem. High energy bills, we're of course trying to avoid, but as it relates to our health, you could also end up with poor indoor air quality, and these things can obviously impact long-term building durability. So how do we address that? Well, one of the recommendations from ACA Manual LLH is supplemental dehumidification. So some of you guys know Nikki Kruger. I don't know who that guy is there on the right in that picture, but Nikki is quite the celebrity. And, she's been out there preaching the gospel of dehumidification for a long time. And, I think, in some ways with the result with the, when LLH was published, her day in the sun has arrived. So I think, like it or not, we realize that most HVAC systems are not going to do the job, especially in these part load conditions. So Supplemental dehumidification is recommended in LLH for climate zones 1 through 4, and that's North Carolina. That's where I live. We're climate zone, primarily climate zone 3 and 4. We got just a little bit of climate zone 5 up in the high country where App State is located in Boone. So most of the state, and really most of the Southeast, needs supplemental dehumidification in these low load homes. And there's even some guidance in manual LLH on how to size these appropriately. These are some of the pieces of equipment that I found in my research. I'm not going to go through these, but certainly I'm happy to make these slides available. And even my graduate research project, if anybody's really bored, suffering from insomnia and needs some help sleeping, I'll be glad to share that with you. So, just some of the conclusions. This is not the conclusion of my presentation, by the way, just my graduate research was that most conventional HVAC systems are oversized for low load homes. The equipment options that are appropriately sized for low load homes have been optimized for efficient, sensible temperature control, but not necessarily for latent control. And this problem is certainly exacerbated by high ventilation requirements that increase the latent load during the cooling season. So it's really kind of a perfect storm, and one of the few options to solve it is supplemental dehumidification. Sorry, I'm talking too much. I think you get the idea there. So final story I want to tell you is about the pocket neighborhood that I'm developing now in Granite Falls, North Carolina. But before I do, I want to tell you about what inspired this neighborhood. When I was working for Mitsubishi back in 2018, I attended the Innovative Housing Summit in Atlanta that was hosted by the Microlife Institute. And the keynote speaker at that event was an architect from the Pacific Northwest named Ross Chapin. And he actually wrote a book on pocket neighborhoods. But the keynote address that he gave was entitled Stronger Together, Innovative Housing Opportunities for Everyone in Our Communities. And with my background in affordable housing with Habitat for Humanity, it's probably no shock that this just really hit home for me. So Chapin's book on pocket neighborhoods, I actually also read this as for a class in grad school and wrote a paper on it. But Chapin describes pocket neighborhoods as clustered groups of homes gathered around an open courtyard where neighbors have a sense of stewardship and the common ground that they share. So one of the unique features of a pocket neighborhood, as you see pictured here, is that central courtyard. So whereas traditional suburbia, we tend to pave a cul-de-sac down the middle and then, cluster houses around pavement. Chapin's view is that, these houses, you can see the large covered front porches there facing that shared green space, and that really becomes kind of an outdoor living room. So you're encouraging folks to spend their outdoor time on their front porch in community with their neighbors. And they typically will have a property owners association that manages all of that exterior landscaping to make sure that everything looks good long term. And you may have heard this term, it's certainly picking up a lot of steam around the country, missing middle housing. This was coined by another architect, Daniel Paralek, and he will often refer to these, instead of as pocket neighborhoods, he calls them cottage court neighborhoods. Similar concept, though. So, he defines missing middle housing as a range of house scale buildings with multiple units that are compatible in scale and form with detached single family homes and located in a walkable neighborhood. And you may have seen this picture that, they developed at his architecture firm, which is Opticos Design. So, we certainly have, let's say zoning across our country is usually either single family heavy or multifamily heavy, like apartment buildings and things of that nature. but we don't tend to allow for a lot of these other housing types. They're literally not allowed by right. So the Cottage Court neighborhood or the Pocket neighborhood that I'm building now, I had to get that approved as a plan unit development through my town. There was nothing that allowed anything like this by right. I think we've kind of covered that. One other thing that I would mention about the Microlife Institute in Atlanta is that they also host pocket neighborhood workshops. And in 2019, I attended one of these where they created basically this playbook or workbook for developers who want to do this kind of development in their hometowns. And they have since developed at least 2, if not 3 pocket neighborhoods around the Atlanta metro. So again, I was really inspired by this to want to do one of these developments back home. So the one that I am working on now is called Duke Street Cottages. And I think I've got a look at the site plan here in a second. But again, my tagline has become, I'm trying to prove that sustainable is attainable, affordable to buy and affordable to own, with near zero maintenance and utility bills, trying to create a sustainable community with shared green space and sidewalks that connect you to downtown. And really want to promote a healthy lifestyle, both outdoors and indoors. So making sure that our homes have healthy indoor air quality through the use of high efficiency filtration and mechanical ventilation. So here's a look at the site plan for Duke Street Cottages. This is a 1.25 acre parcel right downtown. It's across the street from Granite Falls Brewing Company. So I consider it strategically located for that reason. And I'm only able to develop just under an acre because I've got a DOT right of way on the front. Duke Street is a DOT road. And then I've got the Carolina, what is labeled here as the Carolina Northwestern Railroad on the other end of the property. So they've got a large right of way behind me. So, but I was able to squeeze in 11 small lots and again, circling a central courtyard. And you'll see the traffic circulation is around the outside. So we've got a one-way alley, only 10 feet of paving that has parallel parking on both sides. So you park in the back, you come in your back door as sort of the service entrance into the home. And then you eventually spill out onto the front porch, which is again, your outdoor living space facing that shared courtyard. Yeah, I guess just to say, that some of the limitations to this type of development are, as I mentioned before, most towns, their existing zoning does not allow for this type of development. I'm also in the critical watershed for the Catawba River Basin, so you're only allowed to develop, in my case, 36% of the land is impervious area. So I had to get creative with pervious paving, things of that nature, to be able to achieve this level of density. And then, the old not in my backyard. Certainly the surrounding property owners were not too excited about this project when I proposed it. But I'm proud to say that I think they've come around now that they've gotten to know me a little better since I've been not only working out here for over a year now, but I'm now living in one of the cottages on Duke Street as well.
So Rob, the square footage is on those, or maybe you'll cover that in a second.
Yep, I've got it coming up here, and I'm short on time, so I'm going to try to zoom here a bit. But yeah, certainly slow me down on that if you have specific questions on the floor plan. But one of my goals is, for this to eventually be a zero energy community. So all the homes are being built to the zero energy ready home standard, but I'm actually going to put solar on mine. And I'm hoping that some of these buyers will elect to, to upgrade to solar on their roofs as well. So we've at least worked with Southern Energy Management, who's our HERS rater, but they also do solar to look at what the solar potential of the site would be. And as you can see here, we could potentially generate up to 70 kW of power. So we've even talked about the possibility. I've talked to Schneider Electric, in fact, about the possibility of a microgrid. Of course, that's an expensive proposition for a developer, but once we get 11 houses occupied here and have a few POA meetings, who knows, maybe we decide that we want to make that investment collectively as an association. But I'm definitely including electric vehicle charging infrastructure on each home, and the ability to easily add solar, as we're required to do for zero energy ready home. That could also include battery storage. So to Aaron's question, I'm only building 2 plans in this community. There's the, and again, I'm working with Tightlines Designs in Raleigh as my architect, but this is the Howard plan. They actually named this one after me. We sort of co-developed this 2-bedroom, 1-bath plan. So it's pretty simple, 24 feet wide, 34 feet long, plus a 7-foot deep front porch. And we did build these the full width there, as you see in that elevation. So the living, dining, kitchen area is wide open, on one side of the house, and then you've got your private space on the other side. There's a small mechanical closet off the back porch where the heat pump water heater is located, as well as the electric panel. And I've actually got some as-built pictures finally. So we just had our first 3 closings back in January. So we've had folks, living here for, almost 2 months now. And this is the first house that we built and sold, one of the Howard plans. So you get a sense of how that open living area is nice and bright, and really just, wide open. And then the other plan is a 2-story, 3-bedroom, 2.5 bath, right at 1,400 square feet. And, it's more like a townhouse style. It's all living down, all bedrooms up. You do have a half bath, kind of, next to the stairwell there on the first floor. The kitchen is, tucked back in that corner, and then you've got an open living dining area and a little bit larger covered back porch on this one, but very similar size front porch. The master suite is across the front of the house, so facing the shared green space in the middle. It's got a nice big walk-in closet. You've got your laundry in the hallway upstairs, and then 2 other bedrooms and a bath. And there's a couple of pictures of this is actually my house, the one that I'm coming to you live from one of those bedrooms upstairs right now.
Nice.
So you can see that kitchen tucked back in there. Again, nice and bright, big windows, and pretty clean architecturally. Here's a couple of the bathrooms on the second floor, the hall bath and the master bathroom. Just a couple of other construction details I want to pass along real quick. As far as my building envelope for Duke Street Cottages, I went with a SIP product, structural insulated panel. They're made by Eco Panels in Mocksville, North Carolina. I upgraded to the Huber Zip system as the exterior skin of the SIP. Sorry. So of course, all I have to do is tape the seams once I set these panels, and I basically got my building envelope complete. So it goes together very quickly, and as you'll see in a second, I'm getting some pretty good blower door numbers on these things. But one of the unique things about Eco Panels is they use closed cell spray foam in the core of these, as opposed to EPS like a lot of SIP manufacturers. I'm using their 4.5-inch wall panel, which is rated at R26, and their 6.5-inch roof panel, which is rated at R40. I'm definitely you'll see here using a lot of Huber products. I'm using Advantech for my subfloor, their subfloor adhesive product as well, and going crazy with flashing tape and stretch tape and liquid flash, and watching too many Matt Reisinger videos. So it's been kind of fun, to be honest. You get that liquid flash all over you. It's good stuff.
Yeah.
Speaking of Reisinger, he makes another appearance in the presentation. So it'll come as no shock to you guys. I'm using Mitsubishi mini splits on these. I'm using a ductless mini split in the Howard plan, a ductless mini split on the first floor of the Franklin 2-story plan, and then a ducted mini split in the attic of that 2-story plan to serve the bedrooms and bathrooms upstairs. Partner with Broan on my ventilation system, and I just installed the Overture indoor air quality sensors on my house. So they've got that room sensor that's monitoring. You can see all the different pollutants that it's monitoring for, but temperature and relative humidity certainly, but it also looks at total VOCs, CO2, PM 2.5, and they aren't terribly expensive. So I'm excited about this thing. Basically, the idea is it will activate your ventilation system or boost your ventilation system, depending on how you set it up, if it detects an indoor air quality event. So I'm using their ERV, one of the AI series ERVs. I love that thing. Super easy to commission, and it's self-balancing. I mean, it's for the money, it is hard to beat. I'm using their range hoods and bathroom exhaust fans as well. And part of that Overture system is that they have a smart control for the bathroom exhaust fan that's also a humidity sensor. And then the last thing I want to tell you about is we just did an air barrier install on one of the houses. It's actually the only one I've got under construction right now. It's the 2-story Franklin plan. There's a new air barrier business near Charlotte that was looking for a house to do their training on. So one of my contacts at Air Barrier reached out to me to see if I had one that they could use for the training. So I was able to get a discount on this thing. So I thought, hey, let's try this out. I've been wanting to do this anyway. So you'll see the results here. The pre-sealing blower door came in at a 1.64 ACH 50. And then by the time they were finished sealing, which they only ran the system for about 30 minutes, we got it down to a 0.49 ACH 50. So we certainly could meet the passive house standard with that, after they were finished, maybe not before, but, to be honest, I was pretty happy with my blower door number before they started, but we just did the final inspection on my house last week, and we came in around 1.4 ACH 50 on that one.
Nice.
There's some bling for you. Some of the certificates we got on these first couple houses. So we're coming in around a HERS 44 on these, which, again, for it, I feel like there's a little bit of small house bias.
Yeah, for sure, right?
Not a lot of volume.
Even on your blower door test, right, Rob?
Yeah, exactly. Not a lot of volume to go around there. So the fact that we've got a conditioned attic, because we're using the SIP panels for the roof, you get a little more volume up there. But no, I'm really happy with the way these things are performing.
Great.
Here's my last attempt at marketing for today.
I like it. The shade.
How about that acronym?
It's pretty good. Sustainable.
I need some shade in this room right now. The sun is
you should trademark that.
I gotta up my game here. I need some consulting.
Yeah. Question that just came in: are the cottages slab on grade?
So good question. The first 5 are on closed crawl spaces, similar to the ones you saw that I was building in Hickory. However, the phase 2, the next 5 that I'm going to build, I am looking at slabs for those. So, the land is not flat. We're in the foothills of North Carolina here. So we do have some slope. They would be stem wall foundations, and we would, backfill and pour slab on the top of, some rigid foam insulation, most likely. So, but I'm definitely looking at slab construction for phase 2. Just to, I haven't done a slab foundation in years, but I'm pricing it right now just to see how it compares.
Interesting. Well, it'd be fun to have you back and as you go on that journey and learn more about it.
Just make this an annual event, and we'll keep updating folks. How about that?
Yeah. Well, Rob, thank you. I mean, this was really a kind of complete building science journey of you sharing your journey with all of us. And I found it extremely helpful and extremely informative. So I want to thank you so much. This will be uploaded by the end of the week to the EBA Academy. So you can rewatch it there, send it to your friends. And I think we'll put it on our podcast, Better Homes, Better Future as well, Rob.
That sounds great.
Yeah, Rob, I just want to thank you again. It's always my pleasure to get to spend some time with you.
Absolutely. Thanks for the opportunity.
All right, fantastic.
Thanks, Rob.
Bye now.
See you guys.
See you soon.